Okay, grade 5. Today we're going to be working on using strategies for traditional long division and how we go about some steps that we can use to get success with that and a much more accurate answer every time. So before we begin any long division, we know that in our problem of the day today, we ended up with a very large number. We ended up with 176,295 hours, but we needed to break that down into days. So that requires a particular kind of math. If I'm taking a large number and I want to break it into pieces of 24, who can tell me what math I'm going to use for that? Tim? We're going to use division. And there's different methods of division. There's partial quotients. But one of the methods that in grade 5 and beyond you should start using, and it'll really be helpful, is traditional long division. It's probably the fastest, easiest way to break down large numbers. So one thing that you have to understand before we get into division is every once in a while you're going to be asked to use this strategy, and that's guess and check. Guess and check means I use my math facts, what I know about multiplication and different fact families, and apply that to what I'm doing in my division. So I'm going to set up my problem first. That's going to be 176,295 divided by, this is usually a symbol we use in North America. I know some Asian countries do it upside down. And we're going to divide that by 20 in 24 pieces, representing the 24 hours in a day, okay? I'm going to give you some steps, and if you follow these steps and just repeat the process, you should be successful every time. The first step, step number 1, I'm going to drop it over here, is going to be called how many in. That's step number 1. We ask ourselves how many in. And what I mean by that is we have two types of numbers here. The large number that we're working with, that we're breaking apart, is called our dividend. The number we're breaking into pieces, how many equal groups we're doing, is called our divisor. The answer, of course, in division is called our quotient, and that'll go at the top. But step number 1 is always going to be how many in. So the first thing I ask myself is how many 24s go into 1? I use the first digit to the right. How many 24s go into this 1? Into the hundred thousands, or this 1? How many 24s go into the number 1? Alex? 0. Right, 0. So I want you to put a small 0 there as what we call a placeholder, just to make sure you reserve that spot. We know we can't use it. And then I go back and I do it again. If no 24s fit in there, I move it over to how many 24s now go into the whole 17, not just the 1. How many 24s can fit into 17? Tao? 0. Still 0. So make sure you put that placeholder there. And I start over again until I find one that works. How many 24s, except now I go all the way across to 176. And this should work. How many 24s go into 176? Here's where my intelligence and my knowledge of fact families comes in handy. I'm going to do some guess and check work here because I'm not positive. But what I do know is that 24 times 10 is? 24. 240. I'm looking for 176. What's half of 240? 120. So just in my mind, really quickly, I now know that 24 times 10 is 240. 24 times 5 is 120. So where's 176? Who wants to give estimate? Like, what do you think I'm going to... Yeah? 8. 8? Let's try it. Let's try it. 24 times 8. This is where guess and check comes in handy. 24 times 8, I'm going to go ahead and work that through and see how close I am to my 176. 4 times 8 is 32. I put the carry 3. 8 times 2 is 16. Plus the extra 3 is going to be 19. Ooh. Does that fit? No. So what's my next step? Alex, what's my next step going to be? Try another number. But here's what I want you to remember. You have this space in your book, and you're probably going to need these numbers again, so don't erase them. Keep your work outside, your guess and check work, because it might come up again. You'll be like, oh, I already have that number right there available to me. So let's try 24 times 7. Let's work with that one, okay? 4 times 7 is 28. 7 times 2 is 14. Plus that 2 is going to be 16. Oh, that looks like a reasonable number. I go back to my question. How many 24s go into 176? Okay? And now I know that that is going to be 7.
Yay.
So step number 2 is called multiply. Because what I'm really going to do here is I'm multiplying the 7 times the 24, and that's going to give me the 168 that I'm looking for down here. We already know that. We worked that out. So I'm ready to go. There it is. 7 times 24, 168. That's my multiply step. Okay, that's my multiply. Step number 3, once I have the numbers lined up by place value, I can go ahead and do my subtract. And 176 minus 168, let's go ahead and figure that out. 6 times 8 can't do it, so I need to borrow. This becomes a 6, that becomes 16. 16 minus 8, I should end up with 8. And this is a 0, I'm just going to put that there and a 0. So in total, 8. Okay, correct?
Yeah.
Let's move on.
Peace.
Step number 3, if you've done it correctly, you shouldn't be able to fit 24 into your remainder if you've done it correctly. So step number 4 is going to be what we call help. Okay, and what help does is I'm bringing down an extra digit to help out this number, this 8 here by itself. It can't stand by itself. It needs help. I bring down that 2 and make the number 82. And then step 5 is the finale. Repeat until finished. Or until you're out of numbers you're working with, or until you get your remainder. So I did how many in? I multiplied them and got 168. I subtracted and was left with 8. I brought down a number for help, that 2, and it becomes 82. And then I repeat until finished. In other words, I'm going to go back to step 1 here. I'm going to say how many 24s go into 82. I can use my fact families. I know 24, 48. Who wants to take a guess at that one and tell me what do they think is going to be? How many? If you're doing a guess and check, what would you might? Duke, what might you do?
4.
You want to try 4? 24. I'm going to do my guess and check. 24 times 4. You know, over here we did 8. You could just half that, couldn't you?
Yeah.
But let's just do it. It doesn't take a minute. 16. 4 times 2 and 96. Oh, we went a little over. So what must it be? 3. So I'm going to put the 3 up there, and now I'm going to work that out. What is 3 times 24? I do my work over here. That's 12. 3 times 2, 72. Okay, so I figured out how many in. I'm going to do my multiplication. 24 times 3 is 72. And I next do my subtraction. 82 minus 72. And that leaves me with 10, correct?
Yeah.
82 minus 72 is 10. I think we can all agree. How many 24s? It's not going to work. So I'm going to need some help. I call extra numbers down for this help. So I'm going to call the 9 down now. And it goes straight down. It should be straight down. The next number in line. And you should end up with 109 down here. So there's my 109. And I'm back to step 1. How many in? How many 24s in 109? Well, check it out. Let's use our, look at this. we already have, because I kept my guess and check math over here, I know that 24 times 4 is 96. So could another one fit into the 109, or is it going to be left at 4? Who can make an educated guess about that? Tim, what do you think?
I think it should stay.
Would 5 be too many?
Yeah.
Yeah, right? It would go over. I would be over. So I'm going to do 24 times 4. I already have my math. Times 4. And then I know already that's going to be 96. I did my multiplication. I'm on to my subtraction step here. 9 minus 6 is 3. And I'm going to borrow this one, make that a 10, and that's a 1. I'm left with 13. I'm getting closer. We're getting closer to the end here. 24s and 13, it just doesn't work. I'm definitely going to need some help. So I bring down this 5 as help, as an extra number for that help. And now I can go back over to here. 4 is 96. 168 is 7. Use what I know and say, what do we, 5 or 6? What do we think? 5 or 6? What do you think? 5. Let's try it. Let's try 24 times 5. Let's do a little math over here. That's 20. 5 times 2 is 10 plus 2, 120. Yep. Because any more, oh, it's going to be, could we fit it? Nope, that's as high as we're going to get, right? If I went one higher to 24 times 6, I would go over, wouldn't I? So I know the last one is going to be a 5. I do my multiplication, and that gives me 120. I do my subtraction next. 5 and 1. I'm left with 15. You'll notice there's no more numbers over here. Because today's our first lesson in traditional long division, we're going to leave it as what we call a remainder. You can put it as a fraction, you can put that remainder as a decimal, you can do it in many different forms. Today we're just going to leave it as R, which means remainder. So we're going to call it 7,345, remainder R 15. Okay? We're going to leave it there. Later on, we'll learn how to add decimals and get more specific with the remainder. But for today, let's leave it at remainder 15. And this is the algorithm, or the steps we'll follow for traditional long division success. Okay, grade 5?
Yep.